Namaste. Hope you're doing well. Today we'll solve the fourth question of ISI MSTAT 2024 PSA. And yes, it's an optimization question with an element of trigonometry. You are given a triangle with a fixed perimeter, and you have to find the angular situation wherein the area would be maximum. So let's get started. Now, for a lot of connections to be made. First is, how do we connect angle with side, because perimeter is something that deals with sides. And we have this sine formula wherein the ratio of the sine of the angle with respect to the particular side is the same for all angles and sides. So the next thing, how do we connect sides and area? And this is something that we have to know before we enter the exam. This formula, Heron's formula, which gives the area with respect to the sides. This is the perimeter divided by 2. And how do we maximize the area in an easy manner? We can consider the square of this, because then the square root is removed instead of this expression directly itself. That's because it's non-negative, so it's the same. If you have to maximize this, then it's the same as maximizing its square. And instead of going all at one go with the 3 variables A, B, C, the sides, we can go step by step. And what do I mean by step by step? Define your function where the perimeter is given, because S is half of the perimeter, so essentially S being given means perimeter being given. And once you have defined it, the maximization of this thing is the same of maximization of the function conditioned on C, and then the further maximization with respect to C. And this is possible because the function f by nature is bounded, as A, B, and C all have to be less than S. Less than equal to would also suffice. So yeah. Now, working on this function, we have to do some minor algebra, and we would be focusing on areas where A and B are involved, obviously. And we see that there is this x plus y and x minus y structure, which we can write as x square minus y square. And clearly, as C and S are constants for this function, known constants, so this thing is maximized when this thing becomes 0, and that's only possible when B is equal to A. And then we can also find B and A in terms of S and C. So now that we have this part done, we can focus on this part. And we substitute these two with the values that we found previously. And then this could be our function. We take the derivative by using product rule on this and this, and write it in a convenient form. And then we notice that this thing is positive, and this thing is going to determine the sign of the derivative. And we see that all the values that C takes, so the derivative would increase up till this point, and then it decreases. So it means that the function increases up till this point and then decreases, which means this is the point of maxima. And no surprise, it's 1/3 of the total perimeter, and consequently all the sides are the same. And so all the sides are the same, so all the angles also have to be the same. But there was another way to go about this, and that was the AM-GM inequality. Notice that these terms, when we take their geometric mean, which is less than or equal to the arithmetic mean, and then take cube on both sides and multiply with p by 2, we get something like this. And then when we take square root, we get this area of the triangle, that, and whatever this is. The key part is that AM-GM inequality is satisfied, which means they both become equal when the terms involved, which have to be non-negative, which in this case they are, when the terms are the same. So when all these terms are same, it essentially boils down to A equals to B equals to C. So this was perhaps a smarter way to go about it. And yeah, that's it. You get the answer. And it should not surprise, because these sort of maximization problems tend to have a symmetrical answer associated with them. And some ways to build your base is, it is possible to maximize the objective in front of you by focusing on one thing at a time without getting overwhelmed with too many variables. In this case, we sort of focused on A and B first, and then C, and then we could maximize. Yeah, if you are smarter, you can just use AM-GM inequality as well. But yeah, so if you like this, then the request is to identify those 3 things, any 3 things that you think maximize your area of potential. Think about it. Take care. Hare Krishna.